Hello everyone. So today we're going to go over section 4.4, permutations when objects are identical. So in example 1, we have 3 cans that are to be put on a shelf, and we'll begin by listing all of the permutations. So we'll label the cans C, P, and R. And from before, we know that there are 3 factorial ways to arrange these 3 cans. So there are 6 arrangements. And we have CPR, CRP, PCR, PRC, and RPC, and finally RCP. Those are the 6 arrangements. Now suppose R was replaced by another C, then we have the following. CPC, because the first R has been replaced, and then CCP, PCC, PCC, R, sorry, about that, CPC, and finally CCP. So that's what happens if we replace all of the R's with C's. Notice that some of the permutations are now the same. So for example, we have 2 CPCs, we have 2 CCPs, and finally we have 2 PCC. That is to say, we actually only have 3 permutations, or 3 arrangements. And the reason for that is because even though we still have 3 cans, so the 3 factorial still applies, since 2 of the cans are the same, we need to divide by 2 factorial to indicate that those permutations would have been counted twice. So again, that is 3 cans, but 2 of them are the same. So if we were to evaluate this, we have 6 over 2, which gives us, once again, 3 arrangements. And this result can be generalized as follows. So the number of permutations of n objects, where A of them are identical, B of them are identical, and so forth, is listed right here as n factorial divided by A factorial times B factorial times C factorial, and so forth. So next, let's apply this formula to a few examples. Okay, so we have 6 mini boxes of cereal. In this case, then we have 6 boxes, so that's 6 factorial. 3 of the boxes are the same. They are Cheerio boxes. 2 boxes of Fruit Loops, and 1 box of mini wheats. So we can divide here by 3 factorial, because those are identical, times 2 factorial for the 2 Fruit Loops boxes, and 1 factorial for the one box of mini wheats. Let's go ahead and just write down where the numbers are coming from. In this case, the numbers are small enough that we can evaluate them pretty easily. So 6 factorial is going to be 720. And we know that 3 factorial is 6. 2 factorial is 2. And of course, 1 factorial, just 1. So really, we just have 720 divided by 12. And that will give us 60 permutations. Or 60 orders if we were to use the wording from the question. Okay, next example is very similar. So we are arranging 6 flags of the given colors and looking at how many arrangements there are. So in the first case, we have 3 red, 1 green, and 2 blue. And so we have 6 factorial in the numerator. And then we have 3 factorial times 1 factorial times 2 factorial in the denominator. And this is just like the example that we just saw. So once again, the answer is going to be 60. Now, the number of flags is the same in the second example, part B here. The difference is that there are 2 flags of each color. So that's going to be 6 factorial divided by 2 factorial times 2 factorial times 2 factorial. So let's go ahead and evaluate this one. 720 in the numerator once again. And then in the denominator, we have 2 times 2 times 2, which is 8. So we actually have more possibilities in part B. There are 90 possible signals. Whereas in part A, there are only 60 different signals. Next up, we have a very similar one, just a number of permutations looking at words. So the first word has 7 letters. And we are only going to be concerned about the letters that actually repeat. So there are 4 O's and there are 2 G's. Go ahead and label once again why the setup is the way it is. Now we can do this question by expanding the factorial in the numerator first. So we have 7 times 6 times 5 times 4 factorial, so we'll stop there, since 4 factorial also appears in the denominator. And then from there they can be eliminated. So really we just have 7 times 6 times 5 all over 2. And we'll get 105 permutations. Okay, in the second example here, we have 12 letters in the word statistician. And let's look at the repeats. There are 2 S's, there are 3 T's, there are 2 A's, and there are also 3 I's. Just going from left to right. So in this case, if we were to use a calculator to evaluate this, we'll get 3, and then so 3,326,400 permutations. Okay, next we're going to add some conditions to the permutation problem. So first one, we have the word Canada, and the first letter must be an N and the last letter must be a C. So there are 4 letters left over. And what is important to note here is that there are 3 A's and a single letter D. So that is to say we have 4 factorial, because there are 4 letters left over, and then there are 3 A's, so divided by 3 factorial, and that will simply give us 4 permutations. Which makes sense, since the 4 permutations would just be D, A, A, D, A, D, and finally A, D. And that's it. And of course, we also have N in front of the arrangement, and the last letter will be C. Next one is very similar. So we have 3 red blocks, 5 blue blocks, 2 yellow blocks, and 4 green blocks. Now the first and last block must be yellow, so we only have the 3 red, the 5 blue, and the 4 green left over. So that will be a total of 12 blocks. And we're going to be dividing by 3 factorial for the red blocks, 5 factorial for the blue blocks, and 4 factorial for the green blocks. Again, if we were to use a calculator here, we will get 27,720 permutations. Okay, so next is a question that's related, but the setup is a little bit different. So here it says that Julie is trying to go to school from home and only traveling south or east. Okay, and that is the diagram right here. Julie's home is 2 blocks north and 3 blocks west of the school. So again, traveling only south or east, how many routes are there? So there are actually 10 possible routes, and they are drawn here in blue, the 10 different pathways. And the important thing to note is that no matter which pathway Julie chooses, she will always have to travel east 3 blocks and south 2 blocks. So in total, she's always traveling 5 blocks. So that will be 5 factorial for the 5 blocks. And we'll divide by 3 factorial for the 3 blocks east, and 2 factorial for the 2 blocks south. And in this case, let's say we expand partially the numerator. And then we are to eliminate the 3 factorials. Just like so. So we have 5 times 4, which is 20, divided by 2, which give us the 10 roots. Okay. So that's the idea. Let's look at another example here. Again, we're traveling from A to B, traveling only east and south. So we can see here in this case there are 6 blocks in total. Go ahead and add some colors. So east, east, and then 4 blocks south. 6 blocks in total, so 6 factorial is our numerator, divided by 2 factorial times 4 factorial. And just like the last example, we can expand partially the numerator. In this case, the 4 factorials will be eliminated. So 6 times 5 is 30. 2 factorial is equal to 2. So there will be 15 different paths. Okay, so from there we can look at questions that are a little bit more complex. So here we have a bus that needs to go from the station to the concert hall. Notice that there are that this diagram is not just a rectangle. There is a top part and a second part with a single point connecting the two right here. We'll call that point C. So the first part of this diagram, there are 7 blocks, 3 blocks east and 4 blocks south. So here we're looking at 7 factorial divided by 3 factorial times 4 factorial, which using a calculator gives us 35. In the second part, 2 blocks east, 2 blocks south, from point C to the concert hall, so that will be 4 factorial divided by 2 factorial, 2 factorial. And again, using a calculator, we'll get 6. Now, by the fundamental counting principle, in order to count the total number of pathways going from the station to the concert hall, we need to multiply 35, which is the number of ways to go from the station to point C, by 6, which is the number of ways there are to go from point C to the concert hall. So there are 210 paths or routes. Okay. One last example. What if we have something that's the shape is a little bit more irregular? So this time around, the easiest approach is probably to count the number of ways as we go. So from the station, we must move always closer towards the stadium. So notice that from the station to, let's say, this point here, there's only one way to get there. We have to move 1 east. Likewise, at this point, the only way to get there is east and then east again. Same thing from this point in the corner. And so let's travel south. So there's only one way to get to this point. You have to head 1 south. Here there's only 1 pathway, 2 south, 1 pathway, 3 south, and only 1 pathway, 4 blocks south in a row. Now consider this corner. There are 2 pathways. We can go east and then south, that's one way. Or we can travel south and then east, that's the second way. And it works out at 1 plus 1, is equal to 2. So we can just add those together, and we have 2. And so very similarly, if we look at this corner here, there are 3 ways of arriving at that corner. There's 1, 2, and 3. And coincidentally enough, that's 2 plus 1 gives us 3. So this pattern actually continues. We can do the same thing here. 3 plus 1 is 4. And so this corner, there's only 4 ways to get there. We have to get to this corner first, and then just go 1 block east. So that's 4. Okay, so 2 plus 1 is 3. So we're always just adding the numbers from the previous 2 corners. So 3 plus 3, 6. 6 plus 4 is 10, and here we have 14, of course. So we can keep going. 4, 5, 10, 15. So here this will be 15 as well. 20, 34, 35, 50, and then here we have, let's keep going. So by the time we get to the bottom corner, we have 119 different roots. So probably the best approach to this question here, unlike the previous question where we can look at the total number of blocks and then the different blocks that are traveled, this one we have to do this question by adding the previous corners together. Okay, so to recap quickly, the main goal of today is to look at the permutation formula for when some of the objects are identical, and so we did that. We also looked at some questions with cases, and then we did some pathway questions as well. And that's it for today. Once again, thank you for listening.